I welcome you in the lecture series of microengineering. Just I will take a pen. So this is lecture number 14. In this lecture, we are discussing about the ATDs, that is the avalanche transit time devices. Okay. So if you are not watching the videos from first, you can watch through the playlist. If you are not still subscribe my channel, please subscribe the channel. If you are subscribing, then you are getting the latest updated video of each and every video which I have uploaded on my YouTube channel. So you can enjoy the video of DTSP, then microengineering and electronic devices subject. This subject currently I am dealing with this semester. So you can enjoy this lecture by using subscribe the channel. If your friends are also those who are in final years, you can recommend this channel to your friends also. So right now I am having one surprise for you. That is nothing but the Gate 2020 YouTube channel. So as you are in final year now, so now if you are in final year, what is the scenario you know very well? That is anything but the employment scenario. Now near about few lakh students, I will say suppose 10 lakh, 5 lakh, okay, not 10 lakh, but 5 lakh ECE electronics and allied branches students are there, 5 lakhs. Okay, ECE students are there that are right now pass out. Okay, right now they are pass out, and this is the August, and again in few months you are also joined to this figure. So again 5 lakh students will also join, so that is nothing but the 10 lakh students are there. So there are less chances to get everybody get placed or everybody get a job. Okay, job. So what you have to do, you have to be more and more and more knowledgeable and more clear with your concept and all, because the scenario is very vast outside. So you have to be very strong at your conceptual subjects and all that. So for that, gate is the only exam by which you lot of gates are open. I can say that gates are open like PSUs and all. Directly they are recruiting on based on this score of in the gate or exam. Now IIT Bombay is conducting this exam for you. So I will tell you in the first in this lecture, in not whatever this lecture I will give, eligible, what is eligibility, then syllabus, what is the syllabus, then paper pattern, what is the paper pattern of this one, then if you are following me 100% you can crack the exam, and it is obviously free of cost. So what is eligibility, how you are eligible or not, what syllabus is, as far as syllabus is concerned, a lot of stuff is there on the internet. So I am having the experience that what you have to study and what not to study, this is the very important. You have to be choosy. Okay, lot of books you will find and lot of derivation and all that you will find, but if you are following me, then definitely you will crack this exam. Then what is the paper pattern over there, that is nothing but the MSQs are there, that is multiple select question, then MCQ are there, what is the difference in between that, then fill in the blank questions are there, how to tackle with this kind of problems and all, what is the negative marking, how negative marking will impact your overall score, and all that we will discuss in this particular YouTube channel. If you really want to crack this exam, then definitely you have to subscribe this channel. I will tell you afterwards that when I will start this channel, or I will start on this same channel itself. So so we in the last lecture we have discussed last lecture we have discussed about the varactor diode, its construction, its working. Then we have started with the avalanche transit time device. So what exactly mean by transit time? So for example, suppose this is my anode and this is my cathode. Okay, anode and cathode. So we know that electron will generated by this cathode, and they will attracted toward this anode. Okay, and it will get attracted. So whatever the time required by this to travel from cathode to anode is called as my transit time over there. That is nothing but my distance divided by its velocity, that is speed, is called as transit time over there. That is nothing but transit time device. So there are three categories, three diodes are there, that is the impact, BARITT and TRAPATT. So impact and BARITT we have seen in the last lectures. In this lecture we will see about the BARITT diode. Just a minute. So we have discussed this all part. So BARITT is nothing but the barrier injection transit time diode. Okay, barrier injection. So what exactly mean by barrier over there? So barrier is nothing but some kind of obstacle over there. So barrier injection, in that barrier we have to inject electrons on that one. So that is nothing but the barrier. So I will explain this construction. So here the PN junction, normal PN junction is used over here. Then afterward this again NP junction over there. But here you will find the length of this N type channel is very high. Oh, sorry, very more one. That is nothing, very large one over there. So why we are studying this again diode, that ATDs and that all? Why we are studying? Because think about the transponder, satellite transponder is there, transmitter or receiver over there. So at that micro frequency, near about 2.5 gigahertz frequency, we are using at lower 2.5 gigahertz. Okay, 2.5 gigahertz frequency we are using for uplink and downlink over there. Some uplink is having less frequency, uplink is having more frequency, and downlink has have less. So this is very high frequency, gigahertz. Okay, so if you are using normal transistor and that, so inter-electrode capacitance, the lead inductance, this effect will form and they are starting to generate the frequency again. Okay, this is very disastrous thing. So to avoid this thing, we have to go with the diode or transistor. In this particular lecture, we have discussed about only diodes. Next lecture, we are discuss about the transistors. What are the transistors? And this after this, I will declare that this module is over. So in the construction, we will see the PH channel. Just a minute. P channel, then N metal, and SI vapor, that is of N type over there. This is called the drift region. Now drift region is nothing but what? It is all about the forcefully we are doing. We are forcefully moving the electron over there. So now if I am applying the voltage across this two terminal, that is nothing but here we are applying positive terminal. Okay, and here my negative terminal over there. So just a minute, I will give you one example based on this. Suppose this is my 5 volt and this is 1 volt. Okay, that is nothing but the current will flow from this end to this end, higher potential to lower. Now I am having two charges, that is nothing but the holes and nothing but my electrons. So if I am placing one electron over there, so whatever the charge on electron is, 1.6 into 10 raised to minus 19 is the charge of electron. A single electron having this much charge. If I am placing in this one, so this is get attracted toward the more positive charge, that is nothing but here this is get attracted. But same time if I am applying same 5 volt and this is my 1 volt, if I am applying an hole over there, so hole is nothing but it is having positive potential, that is 1.6 into 10 raised to plus 19 coulomb. So what will happen? So that is positive charge particle and positively charged positive electrode over there. So that is more repelled by this one and attracted at the less terminal. So the hole will get attracted toward this terminal, that is nothing but the positive to negative. So from this I can say that in case of electron, wherever there is a current flow, electron will flow opposite of that direction, and in case of hole, wherever current flow, the electron will the hole will flow in the same direction. So that is nothing but it will contribute the both current, that is nothing but current due to the electron and current due to hole in this case. Okay, current and overall current is carried out. So the positive terminal, so holes are getting attracted at this terminal. Okay, holes are getting repelled by this terminal and electron are also attracted at this terminal. Overall current is flowing like this one. Overall current will flow like this one. Okay, overall current will flow like this one. So and the electrons are flowing in this direction, holes are flowing same direction. So this is all about BARITT junction diode. Okay, so this in this case the BARITT diode will work. So we will stop over here. Thank you very much for attending this lecture. Thank you.